Welcome to Coach Taylor's Class Notes, and today we're going to talk about symmetry. So we've got three kinds of symmetry. Sometimes they overlap, but we're going to talk about what makes them different. So reflectional symmetry is, think of a mirror image. So if you were to hold up a mirror at any point in time on the image, you would still see the same image. So think about it this way. You could also fold it in half and you would have the exact same shape on both sides. So when we have reflectional symmetry, we like to draw a line that would represent, oh, that's a terrible line. It would represent that if we held up a mirror right there or if we folded it right there, that it would be reflected. And so on this shape right here, we have one line of reflection. Some shapes will have more than one line of reflection. So the next type of symmetry is our point symmetry. So point symmetry means it has 180-degree rotation about a center point. So that means that if we were to hold the shape and then turn it upside down, it would be the exact same shape. So when we think about it as having 180 degrees of rotation. And so that's point symmetry. It's very, very similar to rotational symmetry, but the biggest difference is that it only has one rotation in which it is symmetrical, and that is 180 degrees. So now we're going to talk about rotational symmetry. So when we talk about rotational symmetry, it means that we can rotate it at any point in time or at any specific degrees and it be the exact same shape. Rotational symmetry also usually, I can't spell today, usually has reflectional symmetry. And so if we were to look at this figure right here, if I were to rotate it this way, it would be the same. That way, it would be the same. That way, that way, that way, so on and so forth, it would be the same. So if I count, I've got 1, 2, 3, 4, 5, 6, 7, 8 points of rotational symmetry. So if I take 360, which are the number of degrees in a circle, and I divide it by 8, I get 45 degrees. So when we are talking about something having rotational symmetry, we also talk about how many degrees it has, and that depends on how many points we can rotate it. So this sun here has rotational symmetry at 45 degrees. We can also think about it having reflectional symmetry because I could draw a line right here and it would be the same shape. I could draw a line right there and it would be the same shape. Draw a line there, draw a line there, and so that would be 6 points of reflectional symmetry. So let's look at some examples. So line symmetry. If I were to draw a line, would I have the same shape? Yes, I believe I would. If I draw a line here, yep, we've got the same shape. And there, yes. So this shape has reflectional symmetry because I could fold it in half upon all those lines and have the exact same shape. So again, point symmetry means it has 180-degree rotation. So if I were to rotate this 180 degrees, I would end up with the exact same shape. So yes, it has point rotation. And finally, if I rotated this 1, 2, 3, 4, 5, 6 different ways, it would have the same rotation. It would have the same shape. So 360 divided by 6 would be 60 degrees. So it has rotational symmetry at 60 degrees. So reflectional means that it's line symmetry or it's mirror image. So if I were to draw a line right down the middle of this A, it would be the same. Or if I were to fold it in half, it would be the same. So my A has reflectional symmetry. Point symmetry is 180 degrees, which means if I look at my A upside down, it is a completely different shape. So it does not have point symmetry. It was supposed to be in green. Give me 1 second. It does not have point symmetry. And if it doesn't have point symmetry, it probably does not have rotational symmetry either. And if we've already highlighted reflectional symmetry, we know it's very much none. So let's look at this shape here. Is there any way in which I could fold this or cut it in half and it would be the same? And I think the answer is no. If I look at the shape upside down, is it the same shape? The answer is no. If I were to rotate it about its center, would it ever be the same? And the answer is no. So none or no symmetry is the answer for this one. All right, let's look at this last one. So can I reflect it? Because if I were to reflect it on this line, this stuff would all come here, which would be a no. If I were to try to reflect it here, everything would come over here. So it does not have reflectional symmetry. Let me get my eraser to confuse me less. Point symmetry. So if I were to look at this upside down, ooh, it actually is the same shape upside down. So it does, in fact, have point symmetry. So point symmetry tells me it's 180 degrees. If I look at it sideways, is it the same? Let me check one thing real quick. I'm trying to figure out if these squares are even or if they're a little oblong. And I would need to get a ruler out, and I do not think I have a ruler. I'm going to say they're oblong and that they are not perfect squares, although it is a perfect square. So if I turned it 90 degrees, nope, if I turned it 90 degrees, it still wouldn't work. If I turn it upside down, it's good, but it would be on the wrong side. So this does not have rotational symmetry, or if it has rotational symmetry, it is technically at 180 degrees. So we could kind of put an asterisk there that its rotational symmetry would be 180 degrees, which is the exact same thing as point symmetry.